Well, so today we have to move on to quadratic sequences. Okay, so if you look at this, right, 5, this sequence goes 5 to 9, you're adding 4, you're adding 4, you're adding 4. So this is a linear sequence, this is what we've been seeing, and that's a linear sequence, right, okay, and where the first difference, and we say, how do you know it's a linear sequence? This is called the first difference is a constant. So the first difference is a constant means the first difference is the same every time. So it's is a constant means you get the same number every time. So first difference is a constant. So the first difference is 4. You're writing on 4 every time, and that's the first difference is a constant, so that makes it a linear sequence. Whereas if you take this sequence, 1 goes to 4, you add 3, 4 goes to 9, you add 5, 7 goes to 16, you add 7, and 16 goes to 25, you add 9. This is not a linear sequence because the first difference is not the same, right? It changes every time. Okay, but if you look at the differences between the differences, so 3, 5, you went, that's plus 2. This is plus 2, this is plus 2. So that's called, guys, the second difference. And when the second difference is a constant, it's a quadratic sequence. Okay, so if the first difference is a constant, it's a linear sequence, which is what we've been dealing with up to now. But now we're introducing quadratic sequences. So when you look at the first difference, they're going to be different, but when you get the difference between the differences, right, okay, they will be, the second difference will be the same, it'll be a constant, so therefore this is a quadratic sequence. Okay? So just one more example here. 1 goes to 6, you add on 5. 6 goes to 15, you add on 9. 15 goes to 28, you add on 13. 28 goes to 45, you're adding on 17. Okay, so it's definitely not linear, right? Okay, so then you check out and you say, well, 5 goes to 9, that's 4, add on 4. 9 goes to 13, that's add on 4. 13 goes to 17, that's add on 4. So girls, that's a quadratic sequence, because, and why? So if you're asked an exam, they'll say, what kind of a sequence is it, and why? And the reason you give is the second difference is a constant. So the second difference is a constant. Now, if we were to get the Tn of a linear sequence, you'd use the formula a plus n minus 1 times t, which is in the log tables. There is no formula for the quadratic sequence in the log tables, so we have to learn how to get the general term, the Tn, right? Okay, so how would I generate it? Okay, so that's the next section, and it's long and it's complicated. That's why I'm making a video, so you can watch it 2-3 times. Okay, right? So finding the nth term of a quadratic sequence. Okay, so finding the nth term of a quadratic sequence, there's no formula in the log tables. Okay, so you have to remember that generally the general term will have something n squared plus something n plus a number on its own. So that's what your answer is going to look like. There's going to be something n squared plus something n plus a number on its own. And 2a, now this is different to the a that's in the form. The a in the formula was the first term. This is not the first term. This is the coefficient of n squared. It's that number there. So this a here has nothing got to do with the first term. So twice the number in front of there is equal to the second difference. So twice the coefficient of n squared is equal to the second difference. Okay, so I'm going to do a couple of examples to try and explain this. Okay, so what we do is, here's my sequence and it says find Tn, right? So if it's a linear sequence, I'm just going to my log tables and filling out a formula. But I look, and this is add 3. And to go from 5 to 10, I've added 5. To go from 10 to 17, I've added 7. and to go from 7 to 26 I've added 9. So it's definitely not a linear sequence, so I cannot use that formula that's in the log tables. Okay, then you see, right, 3 goes to, that's add on 2, 5 goes to 7, you're adding on 2, 7 goes to 9, you're adding on 2. So this is a quadratic sequence. Right, okay, because the second difference is a constant. Now, once you've established it's a quadratic sequence, these two things up here, these two bits of information up in the box have to pop into your head, right? Okay, so that the general sequence, the general Tn value is, it's going to be something n squared, right? So 3n squared, I don't know, plus something n, 5n, plus a number at the end. Okay, so it's going to have that general form, okay? And 2 times a, as in this is a here now, nothing got to do with the first term anymore. It's just 2 times a, the number in front of the n squared. 2 times a is equal to 2, the second difference, which was 2, so that means a is equal to 1. Okay, so for my general term, I already know, I've just figured out that it's 1n squared plus bn plus c. So now I have to figure out b and c. Okay, so if you look up at the term number one is 2, right? Term number 1 is 2. How do I know that? Because they gave me the sequence and I know that's the first term. So the first term is 2. So term number 1 means everywhere I see an n I put in a 1. So it's 1 times 1 to be squared plus b times 1 plus c, and I know when I work all that out the answer is going to be 2, because that's what term number 1 is, 2. Okay, so then multiplying that out, that's 1 plus b plus c equals 2. So b plus c equals 2 minus 1. So b plus c equals 1, and that's as far as I can go with that. Okay, so then you go back up again and you look at term number 2. So term number 2 is 5. So the second term is 5. Okay, so that means into this general here, everywhere I see an n I put in a 2 because it's term number 2. And when I work it all out, I know it's going to work out to be 5. So multiplying out there, that's 4 plus 2b plus c equals 5. Right, and simplifying that, I'll get 2b plus c equals 5 minus 4 when it comes over, which is 1. So I've just taken a shortcut there, I didn't write out. So I should have written out 2b plus c equals 5 minus 4. So that means 2b plus c equals 1. So then I have two equations in b and c, right? So I write one under the other, right, okay, and I write one under the other and I do simultaneous equations. So I'll just move this up. So one equation there is 2b plus c equals 1. The other equation was b plus c equals 1. b plus c equals 1. So then you make the c's cancel, so the same numbers in front of them, but I have one a plus and one a minus, so I need to change the sign, so that becomes a minus, that becomes a minus, that becomes a minus. C's cancel, 2b minus b is b, and 1 take away 1 is 0. So b turns out to be 0. I now have to find c. So c is 2b plus c equals 1. So 2 times 0 plus c equals 1. So that's 0 plus c equals 1. So equals 1. So that means C is equal to 1. Okay? So I said the general term was an squared plus bn plus c. So a turned out to be 1n squared, b turned out to be 0n, and c turned out to be 1. So you don't have to write that, so the general term is n squared plus 1. So that is your answer. Okay, I'll do a second example now. So example 2, right? Here we have 1, 6, 15, 28, 45. Okay, find Tn, right? So you start off and you say that's plus 5, that's plus 9, that's plus 13, that's plus 17. Okay, so it's not a linear sequence. So you go again and you say that's plus 4, plus 4, plus 4. So it's a quadratic sequence. So that's a quadratic sequence. So straight away you can say that the general term is 2an squared plus bn plus c. So that's the first piece of information you've learnt. Okay, it's not going to jump into your head, you need to learn it. Okay, and 2 times a, twice this number is equal to the second difference, which is equal to 4. So if 2a equals 4, that means a is equal to 2. So far Tn, I figured out that this a stands for 2. So it's 2n squared plus bn plus c. Now to get the rest of it, you're going to use term 1 and you're going to use term 2. So you know term 1 is 1. Right? Term 1, the first term in the sequence is number 1. So that means if I put in 1 for n, 2 times 1 to be squared plus b times 1 plus c, and when I work all that out, I know I'm going to get 1 because that's what the answer was, 1. Okay, multiplying that out and moving stuff around equals, that turns out to be 2, and bring it over, you come 1 minus 2, which is minus 1. So there's your first equation in B and C. Okay? Now, the second thing you're going to do is you're going to use the second term. So term 2 is equal to 6. So everywhere I see an n, I'm going to put in a 2. So it's 2 times 2 to be squared plus b times 2 plus c, and I know when I work all that out, I'm going to get 6 because that's what term number 2 is. It's 6. Okay? So multiplying out 2 to be squared, that's 8. Plus 2b plus c equals 6. So I end up with 2b plus c equals 6 minus 8 when it comes across, which is minus 2. So there's my second equation in B and C. Okay? So then I take both my equations. So I have 2b plus c equals minus 2. Was one equation. The other equation was b plus c equals minus 1. So simultaneous equations. Again, I'm going to make the c's cancel. They both have the same number in front of them, right? But it's the wrong sign, so I changed the sign of one of the lines. Okay, the c's cancel. 2b minus b is b. Minus 2 plus 1 is minus 1. So b is minus 1. So then I take either equation, 2b plus c equals minus 2. So it's 2 times minus 1 plus c equals minus 2. So that's minus 2 plus c equals minus 2. So c is equal to minus 2 plus 2 when it comes over. So that means c is equal to 0. So Tn was equal to an squared plus bn plus c. So Tn, I figured out a was 2, so it's 2n squared. B is minus 1, so minus 1n, and c would be 0. Okay? You can write that as 2n squared minus n. So that's the rule to get any term. So if I wanted to get term number 1, it's 2 times 1 to be squared minus 1, which turns out to be 1. To term number 2, 2 times 2 to be squared minus 2, which works out to be 6. Then it's 2 times 3 to be squared minus 3, which is 15, and so on. So that's what the TN rule tells you. Okay? So you might have to watch them a couple of times, girls, to get the idea of them. Okay, that's why I did a video. Okay, and the homework is page 430, number 7. So page 430, number 7, and it is 3 of those. Okay, so do your best. Okay.